So I think this is a good critical mass. I think it's good enough number to kick off. So kia ora koutou, welcome everybody to today's Thought Leadership webinar with the Wellington Regional Leadership Committee. My name's Frida Wells, I'm the Communications Advisor for the committee. And our webinar today is Vision 2030, Building Resiliently in the Face of Climate Change, with our two experts, Kim Aitken and Sharon Robinson. So I'm going to introduce the speakers first, and then we will kick off. So a little bit about Kim Aitken. She's the founder and co-director of Truss House, a New Zealand company on a mission to establish a global framework for cultural, social, and economic equity in housing. Kim believes equity can be achieved if housing is community-led, affordable, scalable, and sustainable. She's passionate and relentless with deep domain expertise, strong technical building science, funding model, and system disruption experience. Kim is currently working with the Construction Sector Accord as part of the industry working group. And Sharon Robinson is the designer and director at Smart Living Spaces, an architectural design practice with people and planet in mind. She's focused on healthy, comfortable, low energy homes and is passionate about sustainable and smart architecture. She has 20 years experience in architecture, and she's also a certified passive house designer with the Passive House Institute and Homestar designer and assessor with the New Zealand Green Building Council. She's currently working with Offsite NZ and Sector Accord to assist with Offsite Space to get building for climate change ready for 2030. So about today's webinar, just a quick run through of sort of high level agenda. The topics to be covered today are the introduction to setting the stage for 2030, the Offsite Space, why Sharon and Kim believe in the approach in New Zealand, in this approach in a New Zealand context and its significance, the design challenges ahead, a look into the hurdles faced in the architectural design and building sector, and collaborations and opportunities, harnessing collective efforts for a sustainable future. And then we will squeeze in as many questions and answers as we can at the end. So enjoy, and over to you, Kim and Sharon.
Thank you. I'm going to chat first, and just to add to the introduction that Frida gave, I think the resounding experience that I have that kind of gives a little bit of a, I guess, advanced experience for a New Zealand context is running and building a business in Canada in a climate where there's 6-month winters, 6-month summer, and really designing for a harsh environment is the day-to-day. And on top of that, there is a element of sustainable design that comes into everything from the structure forward. So I've been relocated to New Zealand. I came here first on a government trade mission between the Canadian and New Zealand government in 2019. I was here in March 2020, right at the outset of the COVID lockdown, and as may or may not be clear by my accent, I am Irish, so I was traveling here on an Irish passport and ended up being stuck in New Zealand for that early part of the COVID experience, and obtained a Edmund Hillary Fellowship Global Impact Visa to remain in New Zealand and work on, this transition from the old way to the new way, and what does it look like to build for sustainability. As Frida mentioned, I'm part of the industry working group of the Construction Sector Accord, with a particular focus on off-site manufacturing, and there's 4 of us in that industry group. And our role, or our goal, is to really make sure that the sector as a whole is ready to adopt what's coming in terms of how to build better houses. And I know there'll be experts on this call who have been waving this flag and have been advocates for this space for a long time. And I think the time is coming, or will be coming very soon, to kind of understand what does it look like to build for climate change. Okay, there we go. So just going to touch on the Building for Climate Change program. This is not a program we are intimately connected with, but as part of the scope under the Construction Sector Accord, we're just looking at what's setting the stage for building in New Zealand. And as Frida mentioned, the context we're looking to provide today is a kind of a high level what's coming, which is what I'm going to introduce, and then an overview of why I believe the offsite construction sector in New Zealand is got the solutions for what does that transition look like, and then we'll go to Sharon for a much more in-depth and technical overview. So the main piece I find myself talking about with this Building for Climate Change is it's not a political agenda. New Zealand has committed to be carbon neutral by 2050, signed it into law under the Paris Accord, and the first step to achieving this goal is a 40 to 50% carbon reduction by 2030. And unlike some other countries, we do not have deep enough pockets to achieve these targets by purchasing carbon credits, which I think is a common misconception. This is the Building for Climate Change work program. It's available online. And I think what we're talking about today are the reporting requirements that begin in 2025 on both operational emissions in new buildings and the embodied carbon emissions for new buildings. And this is quite a new one, certainly in a New Zealand context, the reporting of embodied carbon. And then we look at what are the final emission caps set for 2030. So although this is a 2030 work program, the measurement and understanding around what needs to happen actually begins at this point without any changes to this work plan in 2025. So for a visual, this is really helpful. The carbon footprint of the new build, construction and renovation in New Zealand emits the equivalent of adding 1 million cars a year to New Zealand roads, and that split pretty much evenly between embodied carbon, which I'll touch on, and then operating carbon of this new stock. So we've got a significant issue here in how we're building and what we're building. And I will talk and introduce, without preaching to the converted, what the difference is between the embodied carbon emissions and operational carbon emissions. You'll see CO2e, carbon dioxide equivalent, which is how we measure greenhouse gases. So when we look at embodied carbon as in context, we take what seems to be a simple unit, which is the humble fridge. And when we need to measure the embodied carbon of this unit, we have to look at every component part, what it was manufactured from, how it was manufactured, and the energy that went into manufacturing the individual components, the manufacture of the unit or the fridge itself, what components are scheduled to be replaced over the lifetime of that fridge. So you include any items that have a lesser shelf life and will have to be replaced. And then we have to look at what happens at the end of life of that unit. It's seemingly quite complex, but what we're doing is we're being responsible for the choices we're making and the materials we're using. In a construction standpoint, that translates to looking at the individual components chosen to be used in the manufacture of a house or construction of a house. Then the process itself, what is the process we're using to create that structure? Same concepts, the maintenance over the lifetime of this house, replacing steel, replacing weatherboard, what items will need to be replaced and how many times they'll need to be replaced over the lifetime of that useful life of that building. And then the end of life, what elements of that construction will go to landfill, what will be recycled, what could be reused. And although we're early in looking at the technology around waste minimization, it's an important factor of what we're looking at. More familiar, I think, to most people, operational carbon, if we look at that same fridge, what is the energy reading? How much energy is going to be consumed under normal operating conditions over the lifetime of that building? And that would be more measured in what we would know today around things like passive house. Minimal amount of energy is obviously better for the environment, but also for your pocket. And when we look at that in a housing context, there's energy that's required for heating, separately the energy that's required for cooling, and then the energy of the systems within the home itself. So in this case, a hot water tank, things like your appliances, and then included in the Building for Climate Change program is water use, how much water is being used per liter per day per area of house itself. This is my favorite graphic because it gives a really good visual representation of what we're trying to achieve. So this is the 2020 house, and this is a combination. This is the lifetime carbon footprint of a new home in 2020. You see in yellow here, this is the operational energy, how much energy is used in running the home, and then split out from end of life here in red, right down to the materials used at the initial phase. So this is what we have been doing, and our target is a significant and really profound reduction of that house and its footprint and what it's costing in terms of greenhouse gases. So the future really looks like two considerations. So you've got the what am I building with, the choice of materials. Concrete and steel are the two biggest emitters in New Zealand, using about 50%, I think, overall of or contributing 50% of what's used. And then aluminium, plasterboard, masonry, and framing. Those are all elements that need to be thought about and their use case considered quite carefully. And then looking at the performance of the finished building, things like insulation, which most people are familiar with, air tightness, which is how much does your building leak once you've heated up your air or cooled your air, how much of that just leaks out through the building itself, joinery, and then what systems, fixtures are you using that are low in energy, but also are considerate of things like water reduction. So what is being planned at the moment is that the Building for Climate Change program requires compliance to be demonstrated. So you have to design to meet the target, but also measured or verified at the time of completion. And when I started my business in Canada in 2018, it was about 2 months before the first implementation of a series of the same step changes that are being proposed under the Building for Climate Change program. And it's a massive transition from designing something to then verifying on site, which I know Sharon can touch on, that what you've designed has been constructed and actually achieves the targets that are necessary. In that Building for Climate Change program, there are new measures proposed for building resilience, and this is more designing for climate in its extreme. Flooding, cyclones, everything we've experienced in the last 12 months, earthquake, all of those are factors, wildcard factors that will need to be taken into consideration as the code goes forward. Building as I did, or designing as I did in a structural capacity in an area where, you could have 6 or 8 feet of snow on your roof, you have to consider what the implications of that structural design right down through your components are when things get tough. Just also a helpful, I like to picture things in numbers, but at the moment when we look at what's being built in New Zealand and we really understand, I guess, the implications of the change, is there's around 4 million square meters annually just in the detached houses and low-rise residential construction that New Zealand produces. And when we think of those 4 million square meters, every square meter has to be better. It has to be made of better materials, and it has to do better. So it's got to perform in a way that never really was required before here in New Zealand. Thankfully, lots of other countries have gone through this process, this transition into high performance building. Some countries, such as Scotland, Ireland, similar size to New Zealand, picked the highest requirement and made it all happen in one go. And other countries, UK, North America, have picked step changes. Every year something changes, and as you go, you gradually adopt to get to that higher target. So thinking about that in an industry context, and this is, this is quite high level, but there is generally a knowledge graph across the sector regarding the future code changes that will be required. It's not promoted, it's not talked about. There's not a lot of planning yet in place. We are a little bit early, but that's the point of what we're doing right now, is having these conversations, because from a project delivery perspective, continuously modifying your product or your process or your performance or your pathways to performance, it's highly disruptive. And I'm coming from an offsite manufacturing lens as well as an on-site construction approach. And from the work that we've done within the Accord, there really are 2 distinct categories within industry at the moment. And our goal is to support those who are actively looking to be ready. So 2030 ready, and what does that look like? We look at our fictional ABC building company, there's 2 pathways that have to be considered to be 2030 ready. There's the operational process compliance. Is how I'm building going to get me there in terms of the performance of that end unit, regardless of what the product chosen is to achieve that end target? And then we look at the embodied carbon. So is my system heavily reliant on steel, concrete, aluminium, items that we know are going to end up on the less is more list? But we're also familiar or aware that within this lower tier here, product categories will naturally evolve between now and 2030. So things like your windows, the efficiency of your heating and cooling systems, the efficiencies of hot water tanks, laundry equipment, and low flow water systems, the market will step up as required to meet the demand. So when we talk about being 2030 ready, we're not necessarily indicating that everybody has to step up today, look at what they're doing and create the 2030 house today. It's being aware of what's the responsibility of industry, what's the responsibility of government, and then what will the supply chain naturally adopt in order to really meet those requirements. So it's not as complex as it might appear on the outset. So looking at the cost, the complexity, and the need for certainty, is there an opportunity? And this is a transition into the conversation around offsite manufacturing in New Zealand. So this jump, so from my perspective, coming in from the outside, and my specialist with trusses, my specialty is the frame and truss sector and the utilization of that sector. And New Zealand already utilizes offsite manufacturing in 97% of homes constructed today. We just don't think about it that way. And that comes from the prefabricated roof truss, which has 97% residential market share, and then the use of pre-nail wall systems, which is 90% market share. And that's not globally typical. In New Zealand, in Australia, they use about a 50-50 pre-nail wall system and site framing on or framing wall systems on site. In North America, that's closer to 20% using a pre-nail and 80% framed on-site solutions. So New Zealand is already, whether we are aware of it or not, way ahead of the curve in being familiar with the concept of producing a design outsourcing that to a local plant that is, doing it and has been doing it for a long time, and then utilizing those, in this case, a pre-nail wall system on site to really achieve what needs to be achieved in terms of putting a building together. So the transition to high performance building will touch on the role of offsite manufacturing, OSM, and then there's the modern methods of construction, MMC. There's a lot of bandying back and forth between the two topics. There's prefabrication, there's a lot of umbrella terms. And when we add in, or when we talk about modern methods of construction, we look at things that are not necessarily a manufacturing system or a product typology, but there are softwares, there are design tools, there's lifetime project management. There's a lot of ways to modernize within the construction sector. And these are the views that I'll share on my own opinion on how New Zealand can use the OSM and the MMC to really smooth out what it looks like to build the new way. If we were to really nut it down, high performance buildings is layers of complexity, and that's the days of a skilled craftsman on site creating structures with cut joints, and it was a craft that really transitioned to a qualified trade over the last 80 to 100 years. Trade schools, people going away serving their time, and now we're really at this transition to building science. What is the science behind the design? How does individual components perform, and how do they perform when you combine them together? And the construction sector is probably one of the last to be brought into what might be looked at as the modern way of doing things. There's not a lot of industries that are left that are still doing it the old way. So I think the time is, we're not leading the charge by any stretch of the imagination. A lot of words here, but there's the pros and cons of off-site construction and the pros and the cons of on-site construction. I've just highlighted the ones that I think are important when we consider looking at building for the future. I love flexibility, the flexibility that comes with on-site construction. There is a lot to be said for being able to adapt and modify and really go with the flow. It is the current known way. So everything we look at going forward is this is the way it's always being done. What is the motivator or the lever for somebody to leave the old way and move into the new? Cons of on-site construction, availability of skilled labor is one that at the moment we're on the brink, and give it another 5 to 7 years, especially with the knowledge transition that needs to come. That's going to become a major issue, and I've seen that in North America and back in the UK. Off-site construction is super attractive because of the shortened time frame, and then going forward demonstrated compliance pathways. That is going to be a really critical piece for what we need to achieve here in New Zealand, where the consenting process already is quite complex and takes quite a lot of time. Problem or the negatives around offsite construction is there's a real front-end heavy need to increase engineering, design, and coordination, locking in design sooner than almost up to the day, being able to change or modify. So it's being cognizant that those upfront requirements really need to be thought about. So if I distill it all down to the opportunity I see with OSM or MMC, it's really putting the value in the right place. It's not replacing tradespeople. It's not replacing local factories with monolithic, single source, big production boxes in factories that everybody gets a box and you take it or leave it. It's really understanding the value depending on what your project parameters are, whether it's cost, whether it's speed, whether it's complexity, whether it's simplicity or just volume, just build as many as one can build. It's understanding where the value can be found in that offsite spectrum. As a structural engineer, the compliance piece is a major element for me, where I see the opportunity with OSM and MMC being critical, because the complexity as it increases, so do mistakes and problems and areas that don't become maybe apparent right off the bat. I know in Australia they've got issues like they have had in New Zealand with cladding. North America, there was a lot of water. Water has caused an issue, especially with offsite product. where you can't go in and modify it. You don't know what's behind the walls theoretically, but easier compliance and having a process that's been approved, and then that process is repeated over and over in the factory. And that risk avoidance is probably the third one, where we don't want to turn around in 5, 7, 10 years' time and realize that we made some fundamental mistakes while transitioning from the old way to the new way. And I've seen that with specific types of insulation that goes on the outside of a frame that's not being installed correctly. We don't have, in North America, we didn't have a couple of decades to understand the water had been getting in. It was within 3 to 5 years because of the ice factor. So avoiding risk because a process has been tested and proven, it's highly important. And that, I will now hand over to Sharon to give her views.
Thank you, Kim. So Einstein said the height of insanity is doing the same thing over and over again. And I think Kim's touched on this. We're in a changing environment. We need to change what we're doing. As Frida explained, my background is architecture. I was doing architecture. I was drawing house plans at 7. So this is my passion. This is where I want to make a difference. So I'm just going to touch on, there's lots of changes, expanding a little bit sideways on what Kim was talking about. We are seeing changes in the medium density residential standards, which are coming into effect or are in effect in some places. We've got changes with energy efficiency, water efficiency, waste minimization, and then, of course, operational and embodied carbon. So I'll touch on those a little bit throughout the presentation. I've got a slide that touches on the tools and resources that are available at the moment. I'll give you a crash course in passive house principles, and just touch on a couple of myths with our New Zealand building code that people tend to get stuck on, and then why we should be embracing this change, and just some opportunities and challenges with the medium density, the offsite, and then the energy efficiency and waste minimization space. So that's just me, as Frida said, in all those spaces. Jane Goodall's my hero, and we are the most intelligent creature to walk the earth, and we are destroying our home. So Kim touched on this with the Building for Climate Change. I can speak to this as a passive house designer. Basically, by 2030, we're looking at that passive house standard. Passive house has been around since 1992. Ironically, we only introduced insulation as mandatory in New Zealand in 1978. So 14 years later, in Europe, they were developing houses that we're aiming for in 2030. So it's an international standard, it's an international organisation, it's got over 30 years experience. So it's possible, and there is a track record that we can key into, and there's learnings there. Kim did touch on this with timeframes and process. It's this part, the design and engineering part, that there are amazing opportunities between passive house or energy efficiency or Homestar, because that's the side that we need to have intense focus on the design. So if there's collaboration and everyone around the table, we can really get everything nutted down and actually deliver a faster project that's a high performing project. So the players that are in the space, I'm not in all of these organisations, but obviously a member of Offsite. There's the New Zealand Green Building Council. For you guys who aren't familiar with it, they have HomeFit, Homestar and Greenstar. Greenstar's commercial buildings, Homestar is residential, and HomeFit, which I think will get more momentum in 2040, is the renovation space. We have Passive House Institute, and New Zealand has its own Passive House Institute. Brands is doing a lot of work in this space. They have design modelling with ELF. We've got MB in that space too, obviously with legislation. There's a super homes movement, which I'm not that familiar with, but it's originated down in the South Island with Bob Burnett. And these are the tools down here, this Compare, Construct, Core, LCL Play, and LCL Quick, which are dealing with carbon, life cycle analysis, etc. So I don't want to go into too much detail and waste time, but they are free and downloadable off the brand's website. So they're running free webinars as well, so there's lots of information and lots of opportunities to learn. On our building code and why it's not good for innovation. So and it's a bit blurry, but these details here are window details per E2AS1, which has obviously gained a lot of attention with leaky buildings. And the window hangs on the outside of the cladding. This is a alternative solution that a window manufacturer has come up with, where it's recessing the frame and the glazing in line with the insulation. Here is the code compliant, minimum code compliant detail hanging over the cladding. And this is the thermal efficiencies that you get when you start to pull it back into the framing. So our building code is actually the criteria to build the worst performing building legally allowed at that time. And we don't view it as that. We view it as a target. And the general public think that code of compliance means a quality build. So we really need to start looking at alternative solutions, and suppliers and manufacturers can drive that. I do want to say that H1 is energy efficiency, not insulation. So we have got a bit stuck on that in recent conversations. The second myth to bust is the performance of natural ventilation. So this concept of opening up your windows and just magically having air changes. We need 3.5 air changes per hour. We need to remove all of that stale air out of our homes. Simply opening up our doors and windows isn't allowing that to happen, because that relies on the wind blowing from a certain direction at a certain speed, creating the necessary pressures. So we need to start moving past mechanical ventilation and start looking at heat recovery ventilation if we're to embrace energy efficiency. I'm touching on passive house because I know it, but it is a building that's designed to optimize the health and well-being of those inside it while consuming very little energy. And typically a passive house takes a 90 to 95% less energy per year to heat than a standard house. I'd also say to cool as well. We underestimate what we need to cool. We tend to think about New Zealand houses just needing to be heated. And it's not just for houses. House in Germany, HAUS, means building. So these are the core 5 principles of passive house. Kim touched on these on her slide. Minimizing thermal bridging, so plugging the leaks at the construction stage so that you don't have to pay the price for them in the built stage. Better quality windows. We use aluminium in our windows. It's really good for cooking your food on a stove. And somehow when we put it into the windows, we think that it's going to operate differently. Metal is a very good conductor of heat. So looking at UPVC and timber as alternatives. Air tightness. We generally don't consider air tightness in our buildings, yet it's still a factor. Air tightness means you stop moisture from tracking through your thermal envelope. So we're stopping interstitial condensation. We've had lots of people say, I've put double glazing in my house, I no longer have weepy windows. But if you haven't got an airtight house, that moisture is going somewhere and it's condensing somewhere in your thermal envelope. So we are going to see a new leaky building crisis, and that's going to be from the inside out. So we need to address air tightness, and our new construction is getting more and more airtight. So this won't be an issue in our old stock. This is not an old stock issue. Obviously, efficient thermal insulation, continuous thermal insulation, and then lastly, heat recovery ventilation. It just makes sense to recycle the heat that you've already invested in. So basically, Passive House is a thermal modelling system that allows us to evaluate our energy use, taking into account the losses through the thermal envelope and ventilation. Obviously, when you ventilate a space, you can lose heat or you can gain heat. And then the gains that you get through proper orientation of your windows, and also internal gains from cooking and appliances. Touching on overheating, because I think this is going to become a bigger issue. Down here is the Auckland average temperatures. Here I've marked out the solstices and the equinoxes. There's been a myth that you design for the summer and winter solstice. That's 2 days of the year. But if you notice here, the solar angles in Auckland for the equinox for both spring and autumn have the same sun's angle, yet the temperatures in the equinox in autumn is actually higher than in spring. So we need to shade more in autumn and we need to allow more sun in spring. So we need to start to consider shading in our buildings and external shading so that we can stop the heat from even meeting our internal environment. So why should we do this? As Kim mentioned, hot water and space heating are our 2 biggest uses of energy in our buildings. Here's a scenario, a 200 square metre house that we are heating to 20 degrees and cooling to 20 degrees year round, assuming a power price of 32 cents per kilowatt. That's obviously going to go up in the next 5 years. For a code-compliant house, at the moment, it's looking at 120 kilowatt per hours per square metre. to heat and cool it to that 20 degrees. That means when you do the calculations, the power bill is $7,680 a year. We don't pay that because we compromise the health and comfort of our home to be able to afford to live in it. But if you were to take a co-compliant house today and get it to the performance standards with the amount of energy that you pump into it to a passive house, so we're comparing apples and apples, your power bill will be $640 a month versus $80 a month. So currently a passive house is 5 to 10% more in construction costs. That's right now. If we consider this over a period of 10 years with rising energy costs, what's the true cost of it? So we need to stop looking at construction costs in square meter rates. We need to stop looking at construction costs in initial costs and start looking at over the lifespan of the 50 years that the building code asks us to do as a minimum. Another reason why we should do this, I heard last week that 30,000 New Zealand children are admitted into hospital with asthma-related symptoms, not diagnosed, admitted to hospital. This lady, Catherine Letner, she is part of Asthma New Zealand. She is the chief executive. She has got into the construction space because she has seen the result of us doing these worst performing buildings that we can legally build. So we have one of the highest asthma rates in the world. It's not really a statistic we want to be proud of. And this is based on moisture, mold, not just insulation. The opportunities with the medium density space and offsite construction, there is some resistance to it, but I'm a glass half full kind of girl. So the attached housing typology that medium density is going to offer us allows us to have a new social typology, which people will resist, but there are energy efficiencies with joining spaces together. This is not a great example of it, but if you join two conditioned spaces together that are both heated and cooled to 20 degrees Celsius, you reduce the amount of energy on that shared wall that you lose. The challenge with medium density, again, is the sense of privacy. So we need to make sure we get that right at the design stage, but there's a real opportunity for social connection. We do live quite disconnected lives. I think lockdown and COVID showed us how vulnerable we are with that. One of the challenges, with repetition, the offsite space really does offer us this economy of speed and scale with repetition, but we need to be careful that we don't make those monotonous designs like those boxes that Kim talked about. Again, similarly with set design parameters, we don't want a rigid housing typology. We want the opportunity for economy while still having a degree of flexibility, and it's that middle ground between offsite and onsite, and what's your objectives and your intentions. And one of the others is shared outdoor spaces. With medium density housing, you need firefighting spaces, you need community spaces. So there's a real opportunity to make that a space that the residents can have a sense of belonging and have a sense of ownership over it, but also to bring in more natural ecological spaces. The time on site, touching on that design stage, and Kim touched on this too, about getting it right. If it's not considered in the design space, it's quickly going to become a problem on site. That is going to be very difficult to rectify. But a lovely opportunity with offsite is that we've got less travel time for your tradies, less weather delays on site. The intertenancy walls with joining buildings together, we have got a challenge of creating spaces with good natural lighting, but we also have the opportunity of good thermal efficiencies. With offsite assembly, the challenge is the lack of understanding at the moment. We all need to empower ourselves with knowing not just what we do, but how we fit into the whole process. But the opportunity is better collaboration and innovation with parties, so all sitting around that table at the design stage. Offsite offers this amazing opportunity of reduced working at height. We lose a lot of people on building sites. They're quite dangerous spaces. So the challenge here will be the planning and coordination so that you can reduce that working at height, but the opportunity is safer working environments. And lastly, with waste, there's the challenge of accounting systems. I hear of tradies constantly leaving their waste and not caring because they're on site. No one else is there to see them do it. And it's not my problem. I'm not paid to do it. So with the offsite space, there's that opportunity for more efficient use of offcuts and better accountability of leaving a cleaner site for the next person to move into. Just lastly, and it's been a bit of a crash course, so I do apologise, but this is another saying that I keep close to my heart is plant a tree under whose shade you will never sit. We've been asked to stop competing against each other and realise we're on the same team to create a better environment. The construction industry has so much argy-bargy through it. The bloody architect, the dam builder, and we need to all get around the table and realise we're all on the same team. Our client's not the developer, it's not the council, it's not the builder, it's the future occupants of the spaces we are creating, and undoubtedly the people we will never meet. Just as Catherine Lettner will tell you, it's the children who get diagnosed and get hospitalised every year with asthma. So that's my crash course. Thanks, Freda.
I've just had a chance after I presented to look at the list and see the number of people, and thank everybody for their time this morning and attending. And, you know, please do put questions in the chat. And I've got a really quick run through on just a personal collaboration on a 2030 project that we're working on. But yeah, I'd love to see some questions or any follow-ups that people might have. Yeah, thank you for being here, and I've got this opportunity to share this collaboration between Truss House, which is a company I'm co-director of, and Alexander Construction, and the decision to share this was more around what does it look like going forward, echoing what Sharon said beautifully around this is a collective effort. This is not every man or woman for herself in their silo, you know, competing to do it their way. I think we've got this opportunity now to really step into the new way of working that goes beyond product selection and choice. I'm going to talk today on behalf of Truss House and of Alexander Construction, a project partner of ours in Hawke's Bay. Just briefly, we're a bit of a shadow organization. We haven't formally launched in New Zealand, and this is a concept that we worked on in the Canadian market for a couple of years. We've built 18 different typologies of housing. And at Truss House, basically, we use the established frame and truss network across New Zealand to produce low-cost, high-performance building systems, turning the traditional 97% of market share truss roof system into an entire frame system to allow up to 15,000 truss houses a year to kind of become integrated into the New Zealand market without investment in infrastructure, factories, any supply chain disruption, or the requirement for any additional personnel. And this is my personal project passion, which is high performance housing being for everybody at the very minimum, really good boxes. Truss House is just a method of framing. We have an architect sketch. This is just an example. Choose a frame typology. There's an unlimited shape, size, orientation, pitch, slope, and use case. These Truss House frames, they get assembled on site, as this one here was, all frames or a combination of frames and pre-nail walls. And then what you inherently have is this high performance building envelope with wider walls, reduced thermal bridging, highly engineered and rigid in all the right places when we think about the future resiliency. The one we've built in New Zealand went through a tornado earlier this year and came out pretty much unscathed. And we do not build, we are not the builder. We have a system that is available for all the builders, you know, all the government organizations. The client is whom the client chooses to be. And we've got 4 different typologies that we offer here in New Zealand, which are single-story houses with a suspended floor, single-story houses on a concrete slab, and then we've got 2-story and 3-story systems. We have just developed the 3-story system in the last couple of months. We do this in a very simple way. We charge a license fee for every system that is sold, and that is approximately 10% of the overall cost at frame and truss end of the housing system it represents. And we are covered under 3 sets of patent intellectual property for the system typologies that we've mentioned. So that model that we've adopted, we were the builder in Canada, and we realized the limitation as an organization of being the builder comes back to where does the value sit? Our value sits in what the system typology is, how it gets used, and what it means for a company or an organization to have access to this locally available system. And also, from our perspective, allows 99% of the project revenue to stay within the community. Alexander Construction is our project partner for the Hawke's Bay region, and what we're developing is targeted really at the shortage in that region of houses prior to the cyclone. And now going forward, there is, you know, an ever increasing need to build better than what was there originally. Alexander as an organization have been around since 1947, and they have a very strong mandate around producing quality buildings. That's the first thing on their list. They are hyper focused on cost management and defending a client's budget. They have a high business ethic, with all parties in the industry, which is beautifully written. They're energetic and motivated in the marketplace, and they're committed to sustainable green building procedures. And they've got, they're across Hawke's Bay and Manawatu. They would be an example of an organization who have stepped up to be 2030 ready. A couple of their projects, Retirement Village, Castle Hill Winery, the aquarium in Napier, and from Alexander's perspective, moving forward towards 2030, they were looking for a typology that would allow collaboration with their existing network, but also being future ready to adapt to what was coming. So this collaborative approach, Alexander are the lead and partnered with ourselves, Truss House, their local architects, Studio 26, Tumu Frame and Truss, and EB Consulting Engineers. And this project is a 3-bedroom, compliant with the Kāinga Ora M255 design regulations for use of space for government housing. They deliver for Kāinga Ora as well as market. And this particular structure is designed using the Truss House system. And what that looks like is Tumu ITM created a frame system for Alexander to be able to use to build this housing typology in a number of days. Start to finish construction time would be 3 months off-site to deliver on-site. And very simply, Tumu has also come up with a layout on how these trusses get assembled on site. Very simple, and critically for the supply chain that Alexander operates in, all covered under existing New Zealand certifications around PS1 compliance. You know, this is a process that speeds up the code of compliance and does not add additional layers. Studio 26 had free reign to design the use of space. They've got vaulted truss. They've got open living space, they've got these tall windows, calculated natural light, and the beauty for the architect who has a long-term relationship with Alexander Construction is using the truss house frame allowed them to design to their clients' needs without modifying or adapting the process in too many different ways. So the end result is that Alexander Construction, the collaboration, they can construct hundreds to thousands of homes, either an on or off-site solution. And the off-site solution is possible because the frame systems come already pre-assembled, and the assembly off-site is a really quick process. So there's not a large infrastructure. They've got land that they're going to use to do the off-site manufacturing, or the system typology can be built on site. What Alexander were looking for when we initiated this relationship was how to maintain their existing supply chain. They wanted to work locally, they wanted to use a local supply chain, and they wanted to keep their existing design team where possible. And that design team are the same as they were, but they are now using this process DFMA, which is designed for manufacturing assembly. Right at the outset, they're designing everything to be manufactured. Probably the most interesting bit is Alexander Construction can now produce a series of Homestar 7 or 8 builds across 1, 2, or 3 stories. Currently, the pricing sits at or below the equivalent market for a traditional code compliant home. And this was the goal when we started the company, to get high performance housing down to that price point where it didn't become a luxury, it became a bit of a no-brainer. And also 70 people that work for Alexander Construction, nobody loses a job. Everybody who's existing within the organization can build using this typology without any additional training or certification. These homes are 2030 performance ready, and the targets can be easily achieved today for newer existing market and government client base. And Sharon, who did the modeling, and we're sitting around the intermediate cap for building to climate change. But Mark at Alexander Construction knows that he can achieve the 2030 compliance with these higher spec windows and systems when they come. So it's a recognition of being 2030 ready within his entire organization across residential and small scale commercial. And that is, yeah, final slide, what it looks like to work with Truss House in this case. Mark's produced or put together his team, build, design, his local frame and truss, and his structural engineer. First project, which is this pilot process, we consult, we provide the license, we provide all the CAD files, material specifications, we work with the designers, the engineers, and the team, and then that knowledge is transferred. Second, subsequent projects, we provide a license and we liaise if necessary, and the end result is a delivery of market and government residential commercial units up to hundreds a year he's replacing stick framing, and the business is serving an extensive existing client base. And the long-term high-performance construction methodology has been established. And that is it. Thank you very much, everybody.
Well, a huge thank you. This is such an important topic. And the questions have been pouring in, which I think is a reflection of that. So I'm going to try and get through as many as possible. Kenny asks, I can see from how Offsite build, they work well on flat sites, but New Zealand's pretty hilly. Can you comment on the effectiveness for our topography, please?
Yeah. Do you want me to speak to this, Sharon? I can touch on this from a structural standpoint.
Yeah, I'll chip in. Everyone?
Yeah, it's a great question. That really comes down to design. So the main point to think of with Offsite is the typology chosen. It's not all and everything. You know, there's a real flexibility depending on the system topology. So working in an overseas context in a very similar topography, there is nothing to prevent a concrete lower floor and a modular upper floor, or a pile system, pinned back into the hillside. So I think the flexibility comes down to understanding, which is the work being done right now, the Accord is doing around what's available, and this will come up next year, what are the different typologies and what are they suitable for, but definitely assuming that everything offsite is a full house, box style, produced in a factory, take it or leave it. There'll definitely be information around how to build flexibly with different geographic considerations.
Yeah, I think building on that with what Kim says, Offsite has components, panels, and then the modular build. And I think typically when people hear Offsite or prefab, they think those 1980s classrooms and it's a box that lands on the site, but it's actually not. There's people who have got aluminium screw piles for foundations that are prefabricated. They can go in and lay down a suspended floor foundations in a day. So it's evolved so much past just plonking a box on a site. So for those hilly sites, you'd have to choose the components and the design methodology and the construction methodology that fits that specific site.
Yeah, I'm just going to keep smashing through these. Thomas Denhart asks, construction costs versus operation costs, Sharon. How do we communicate these benefits that you demonstrated to those who are conducting the feasibilities, since construction costs, i.e. construction loans, are typically the highest funding milestone in property development?
Yeah, it's a tough one. I know Thomas is an architect, so I can speak to this, that we need to, as design professionals, we need to change our language. We need to not speak to the technical side. As architects and designers, we're incredibly good at selling our services to other architects and designers. We're quite poor at actually speaking to what's tangible and relevant to every day. So talking about power bills, talking about people's health, talking about their child's health conditions, and really just getting some understanding around it and not being scared to delve into that. That I see as being the first barrier. There's going to be a lot more, but I think, and also educating people, not being so precious about what we know, will go a long way.
Yeah.
Excellent answer. Sorry, Kim.
No, I was going to say that nailed it perfectly. And I think it's that conversation around value. I see somebody's question the things like the value of a Homestar or Green Star at the moment doesn't, it's not a consideration. I think, I know that there's a potential plan in the works for buildings to be energy rated. And I actually have a qualification for a different country to do this assessment of an existing home. And suddenly it becomes relevant when that power bill, as Sharon touched on, is predicted to go up 500% between now and 2030. So in the current moment, it's still a luxury item to have because the premium price has been paid to have something like a passive house or a high performance house. And there's a lot of resistance, certainly within, those who produce for government, the requirement to even do Homestar 6. And I think, unfortunately, regulation is the lever that forces change in a lot of cases. And that's what we're facing as a country.
I won't be doing it until about 12.
Just a reminder to mute your mics, people. I'm just going to do that for Roger. There you go. So Kim or Sharon, if you see a question that you really want to answer, please jump to it. Mika Zollner, it's a good question. Thank you for your presentations. Beyond the building code, what's your view on access to transport choices being considered as part of the operational energy of a building?
Sorry, that's in terms of building in proximity to public transport. Is that what the question is?
I read it slightly differently, but you go first and then I can follow up.
Access to transport choices being considered. as part of the operational, i.e. it's a location. Yeah, and I think that goes to the conversation that Sharon, you were talking about, the medium density housing, and I think the location in that urban setting and the need for densification versus a greenfield development, 40 minutes to an hour away. And that really comes down to a lot of that high density is driven by developers and government. This is not a conversation that as individuals we can necessarily influence on a site-by-site basis. But I think it is a real important factor when you look at that high performance building. I think somebody else asked the question about it, 200 to 300 square meter, giant houses out in the country. That sits very much in the niche percentage of the market that one-off houses here and there are not what we're concerned about. We're looking at this mass transition to the typology of housing that is prevalent in New Zealand, of that 4 million square meters from group home builders through to the high density space. Have you got thoughts on that, Sharon?
Yeah, so Homestar is starting to look at that with social amenity, because there's that whole part. So I did just want to say that ANZ is offering reduced loans on a Homestar 6. So we're starting to see that as a system, which will energy rate homes come into that space. But yeah, there are going to be incentives that will grow as the market evolves to considering transport choices. Mika.
Thank you. Brent Goodwin asks, what about reusing existing buildings?
Yeah, I think I can't remember the exact wording, but the number one step is not to build a new building at all, if you have the choice. I think Sharon did touch on at the moment in the Building for Climate Change program, there is a 2040 requirement. Once the new build transition has happened and those, let's call it those products, those higher performance products have become embedded in the supply chain and are a much lower cost or wider availability of choice, then there is a program of retrofit that starts in 2040 and runs to 2050 to kind of get the 80% of buildings that are already built, of what will ever be built in New Zealand, 80% are already built, up to the standard that's required to. There's not a lot of point in making that 20% of buildings, optimum, and the other 80% is, are not running in a way that's in any way conducive. And I think that supply chain and the tools that are in place to do that renovation is quite often a question I get asked. If I theoretically bought a house that is from the 1990s, there's a lot of responsibility going to fall on the homeowner to make those conscious choices around before they're even, I guess, pushed under regulation to do it. And the easiest way to do that, from my experience overseas, is implementing a building energy rating assessment system or a typology where you look at, I've got a D, how do I get to a B? And that started with the rental market when I did this in Ireland, so that a landlord could not rent you a building that you were not aware your electricity bill was going to be $500 or $600 a month. But what that conversely does to things like your mortgage and your affordability or your ratio, and I've seen this in Canada, is you can go in and borrow more money when you can demonstrate that your operational costs are much lower. So it's very much, you win and you lose depending on how you look at it. Those who are individually in their own home, being aware now that in the next 15 years, the likelihood is, things like windows, air tightness, better performance systems, heating and cooling systems, they're all big ticket items that need to be considered as an imperative going forward.
And just building on that, Kim, is that this is a new space for all of us. It's easier to get the learnings in a new build than it is to do it in a renovation. Renovations are more expensive, they're more complicated. So we're all learning in real time. These conversations are important, and hopefully the learnings in the new build we can then carry into that retrofit or that renovation space, which will be more challenging.
Yeah, and I'd just like to answer Bruce Anderson's question, which I think is a really critical step, is what is the next major step that everybody needs to take to operationalize. And I think what we've started today, and what I think all of us, Sharon, myself, and Frida, are hoping is to stimulate the conversation and kind of bring out of the darkness and open up the conversation around what does the future look like. And I find that is the most important first step, because I know from my experience from talking to people and sharing presentations like this, people go away with a different view on what they're looking at. They look at construction differently. They know what to consider differently. And that's why we're doing these conversations in 2023, even though this is not a formal program of government or any sort of formalized process. It's industry need to lead, much as there's a potential reliance on the government to be, setting the standard and leading the charge. Industry have a responsibility, because at the end of the day, as an industry, wearing my industry hat, those of us who are not ready will suffer. We will be the ones forced to pivot. We will be the ones who adopt a system that might not be a long-term strategic play from us. And I'll only go on obviously we've got other project partners, but the conversation with someone like an Alexander Construction, they're risk averse due to the responsibility they feel to their 70 employees. They're not going to take something on that could jeopardize the future of people who've worked in an organization for 30 years. So when they go out looking, they need time, they need certainty, and they are not in a position that they're going to pivot last minute and put all of that at risk. And I think that's our responsibility as an industry to make sure our segment is covered. And I love Sharon's point about sharing. Why, sure, Sharon is a consultant, I'm a consultant. That doesn't mean that the information we hold gets released with, here's a contract, tell us what you know. That needs to end rather quickly. And this, I think, hopefully is the start of those conversations.
Thank you. Joe has asked, what regulatory changes need to happen to make these changes more attractive?
Yeah. I think it needs to be incentivized. I think that there's already a regulatory that it's coming. We'll have energy modelling for building consents in a couple of years. We'll have carbon calculators that will need to be submitted at building consent in 2 years' time. It's the carrot and the stick. This is where I'm hoping Homestar and the likes will step up, and where lending criteria like lenders like ANZ will recognise it, that they've got better assurance, because you can't have one without the other. Otherwise, it just people are going to resist. So yeah, we're figuring this out in real time. So in 2 years' time, I think we're in for a big change in how we submit for consent. And hopefully the incentives will have kept pace with that.
Yeah, and I think the incentives, when we look at from a personal perspective, when we engage with a client, we talk about readiness. There's a need to be prepared and a need to be ready. And those who are probably in the probably the biggest, what we'd say, position of risk, or is anybody who's mandated to provide housing or provides housing under from community level all the way up to something like a build for rent. Those are the drivers in this country, the government housing, the community housing organizations. And the attractiveness of those changes is 100% as a solution to not being forced to make decisions and end up in large budget overruns or uncertainty or projects that don't get finished. So there's a real risk. Being risk averse is really the carrot at this point, is being prepared as to not be forced to change without, enough information. I guess it's a bit of a convoluted answer, but it can't be stressed enough that just having conversations, talking to your own design team, talking to your own build team, talking to your own community, talking to your own council, having that conversation and really, we know changes are coming. What do you need to see from us now, or when the time comes, for us to make sure we don't end up in operational delays or, supply chain delays? It's just opening those conversations is really the first step.
And asking yourself how valuable your home is going to be in 2030, when an energy efficient house is available next door to what you've got. My uncle told me your house is only worth as much as someone's prepared to pay for it. So it's kind of just, it's trusting that and looking. We don't all have crystal balls. None of us have crystal balls, but it's looking ahead and saying, what's the likelihood of my house being valuable in 2030? So what am I doing now? And what's the longer term return on my investment?
100%. I guess to wrap up, stepping back and taking the sort of big picture view, it's sort of like New Zealand's been trapped in this number 8 wire minimum cost lens at a huge expense to our health lens and our social connection lens and our environmental lens. This awareness is that key step that now that we know, and making that decision based on, do we need to build things that are going to give kids asthma? And I grew up in Nelson, where I was blessed with warm, dry weather 300 days of the year, sort of took it for granted. All my cousins who grew up in Wellington, where it's quite damp, have asthma. And it's just, I'm not a scientist, but anecdotal evidence. And I really love that quote, plant a tree under whose shade you will never sit. I think it's a mindset and a values stance. Yeah, so just a real pleasure to host you today. And are there any last comments that either of you wanted to make?
Oh, just a thank you profound to the people who showed up, to Frida for organizing this, to Sharon for being an incredible, knowledgeable partner in in this process. And I think for everybody going forward, you touched on the number 8 wire mentality. That does not need to go away. If anything, New Zealand needs that mentality and to apply that to the future that we're looking at. The innovation, there isn't a massive amount of construction innovation support in industry. And I think that's where New Zealand will, by default of who Kiwis are as a nation, come up with ways that the rest of the world have not considered. Nobody wants the same box as their neighbor repeated 100 times. So let's see what New Zealand can do, both industry and government, to do it in a way that suits this country and the people in it. And it doesn't have to be a big, scary proposition. So thank you for allowing us to have a platform to discuss.
100% agree with Kim. Frida, thank you so much, Kim. Thank you. And to everyone who showed up. Yeah, these conversations are important. So thank you. Thank you for being a part of it.
Thank you so much. And I will send everyone the websites and LinkedIn links for Sharon and Kim. And I'd encourage you to just keep in touch. So we sometimes think, I don't have time to go to a webinar and have this conversation because my day job is so busy, but it's actually these conversations that are, really kind of filling the cup and yes, connecting in with that community that supports you and sleeping easier at night, knowing that you're doing things that you can feel good about. So huge thank you, everybody. And yeah, well done. That was absolutely brilliant.